Hello, today our class is on weighted average of relative indexes. Okay, and tests of index numbers we'll discuss. Uh, Weighted average of relative index. Okay, uh, the weighted average of relative index is obtained by multiplying price relatives of different commodities by their respective assigned weights. Okay, and averaging the total product by using either arithmetic mean or geometric mean. First, we will see the procedure when arithmetic mean is used. Okay, when arithmetic mean is used, uh, certain procedure adopted. That is, in the first step is find out relatives of various commodities by expressing current year price as a percentage of base year price, current year price as percentage of base year price, right? And the second step is calculate weights for various commodities by multiplying base year price with base year quantity. And third is multiply the price relatives with weights. Fourth is obtain the total of value weights. Fifth is divide the product of price relatives and value weights by total of value weights. The resulting value is the weighted average of relative indices. Okay, index we call it as. The formula is P01 is equal to sigma PV by sigma V, where P is the price relatives, that is P1 by P0, small P1 by P0, as we have earlier discussed. P1, small P1 indicates that prices of current year by prices of base year into 100, right? V is the value, okay, where V is the value weights, that is value is measured in terms of product of price and quantity, that is this is base year price and quantity, base year price, and that is P0 Q0. Okay, V is equal to value weights, that can be written as P into P0 into Q0. P0, small P0 is indicates that it's a base year price, Q0 indicates that it's a base year quantity, right? Sigma P, sum of the products of price relatives and their respective value weights, where sigma PV is nothing but sum of the products of price relatives and their respective value weights, right? We have discussed value weights and price relatives earlier class, and right, sigma V is equal to sum of the value weights. Sum of the value weights is given. For better understanding, we will consider a few problems in this. First, we will discuss construction of weighted average of price relatives by using arithmetic mean. Here, commodities are given, and 1975, 1983, the prices are given, quantity are given. Okay, first prices we'll see in the 1975 prices are commodity A8, B10, C20, D12, whereas quantities are 90, 100, 150, 60. In the year 1983, the prices are 10, 12, 25, 15, and in, quantities are 130, 120, 300, 80. Okay, with the given information, first we need to find out the price relatives, that is P is equal to P1 by P0 into 100. P1 is the current year prices by base year prices, right? Current year prices, here we have 8 by 10 is nothing but 12.5 into 1.25, which is equal into 100 is equal to 125. 10 by 12, that is current year prices 12, 10 base year prices are 10, then 12 by 10 is nothing but 1.2 into 100 is equal to 120. Then 25 by 20 is equal to 12.5, 1.25, which is into 100 is equal to 125. The same manner, we need to calculate the price relative for the last commodity, that is D, and that is 15 by 12 is equal to 1.25 into 100 is equal to 125. These are the price relatives, okay, corresponding to different commodities. Now we need to calculate the value weights. Value weights, how could we get the value weights? By multiplying the base year prices with the base year quantity, the seeds. Okay, base year prices with base year quantities. Base year prices and base year quantities are given here as okay, that is V is given as base year prices, that is 88 into 90. 8 into 90 you will get 720, and 10 into 100 you will get 1000. Next 20 into 150, that is 3000, and 12 into 60 you will get 720. These are the value weights. Okay, if you add all these things you will get sigma v, that is called 5440. Then we need to multiply p we got as price relatives, and we know that value relatives, and both are multiplied. If you multiply 125 with 720 you will get 90,000. 120 with 1000 you will get 1,20,000. If you multiply 125 with 3000 you will get 3,75,000. And lastly, for commodity D, if you multiply the price relative with the value relative you will get PV, that is 125 into 720 you will get 90,000. If you add all these values you will get sigma PV, that is 6,75,000. Now we need to substitute the same in the formula, that is P01 is equal to sigma PV by sigma V. Here we know that sigma PV is equal to 6,75,000 and sigma V is equal to 5,440. Substituting these values in the formula, P01 is equal to 6,75,000 by 5,440, which is equal to 124.08. Therefore, the price index for 1983 will be 124.08, right? Next we will consider another problem for the better understanding of this weighted average of relative index by arithmetic mean. An inquiry into the budget of middle class families in a village gave the information, that is expenses on food, rent, clothing, fuel, others are given, and that is also expenses given in the form of weights. The 40% for food, 10% for rent, 20% for clothing, 15% for fuel, and 15% for other miscellaneous, right? And prices in 1981 is given that food has 80, okay, and rent 20, clothing 80, fuel 10, others 50. Price in 1983, food 100, rent 30, clothing 90, fuel 20, others 60. Okay, he was asked to compute the index number by using weighted arithmetic mean of price relative method. Now in order to solve this problem, first we need to calculate the price relatives. That means price relatives p1 by p0 into 100, and value weights we need to calculate. That is v has given in value weights need not to be considered, calculated, but whereas given p0 and p1, the prices in the 1981 is considered as base year prices, and the prices in the 1983 are considered as current year prices. Okay, in order to get p price relatives, p1 by p0, that is 1983 price by 1981, 100 by 80, that is 1.25 into 100, 125. In the same manner we calculate for all these things. 150 by 30, that is 5, 150 by 30 by 20, that is 1.5 into 100, 150. 90 by 80, that is 1.125, that is into 100, that is 112.5. and 20 by 10, that is 2 into 100, 200. 60 by 5, 50, that is equal to 1.20. 9 to 100 is equal to 120. Right, now we need to calculate p. We have calculated, and we have given in the problem itself, and we need to multiply both. That is 40 into 125 is equal to 5000. 10 into 150 is equal to 1500. 20 into 12.5 is equal to 2250, and 15 into 200 is equal to 3000. 15 into 120 is equal to 1800. If you sum up all these, if you add all these, you will get sigma PV, that is 13,550, right? where now we need to substitute the same in the formula, that is P01 is equal to sigma PV by sigma V. Here we know that sigma PV is equal to 13,550 and sigma V is equal to 100. Substituting these values in the formula, that is P01 is equal to 13,550 by 100, which is equal to 135.5. Price index for 1983 is equal to 135.5. This is the answer, right? And now we need to consider another problem. Okay, that is here it is given computation of price index, I was asked. Okay, and here food is given, a group of items that are given: food, fuel, clothing, house rent and others. Index numbers I is given and weights given. We need to find out. Okay, I is given, only we need to find out sigma IV by sigma we need to calculate. Okay, that is I is 350, 200, 240, 180, 200. Okay, whereas weights are V indicated with V, 50, 20, 10, 15, 20. Now see, we require according to the given formula, sigma P01 is equal to sigma IV by sigma V. Hence we need to find out IV. I into V, that is index number into weights, that is 350 into 50 is equal to 17,500. 200 plus into 20 is equal to 4,000. 240 into 10 is equal to 2,400. 180 into 15 is equal to 2,700. 200 into 20 is equal to 4,000. Then sigma IV is equal to, if you sum up all these, 30,600 you will get. Okay, whereas V values, if you add sigma V is also required V. Hence, if you add all the values of V, the weights, that is sigma V is equal to 115. Now, we need to substitute the same in the formula, that is P01 is equal to sigma IV by sigma V, whereas sigma IV is equal to 30,600 by sigma V is equal to 115, which is equal to 266.1. Therefore, price index is equal to 66.1. Right. Now, we will consider geometric mean. When geometric mean is used, weighted average of relative index, how could we find out? There is a procedure for this. Okay, instead of arithmetic mean, if geometric mean is used to average the sum of the product of price relatives and weights, procedure adopted for this is, first we need to find out the price relatives and obtain logarithmic values for various price relatives, multiply the log values of price relatives by their respective weights, add various weights, divide the product of log values of price relatives and weights by the total weights. Okay, find out the anti-logarithm value for the quotient obtained in the step step 3. The resultant one is the weighted geometric mean of price relative index. Thus the formula is antilog of, okay, P01 is equal to antilog of sigma V log P by sigma V. Okay, sigma V into log P by sigma V. That means V into log P we need to add, right? First we need to find out the price relatives, and for them we need to find out the log values, and log P values should be multiplied. The price relatives of log P values must be multiplied with given weights, and the quotient is divided by the sum of the weights, right? Where P is the price relatives, that is P1 by P0 into 100. V is value weights, that is P0 Q0. Now, for better understanding, we will consider one problem here, that is okay, compute price index by weight average of price relatives method using geometric mean is asked. Items are given: sugar, rice, wheat, johar, dal. Base year is taken as 1980 and current year is 1983. Prices are base year taken as P0, okay, and quantities are as Q0. That is, prices are 3, 4, 3, 2, 5, and whereas quantities are 30, 50, 40, 20, 10. Current year 1983 prices are considered as P1. P1 is equal to 4, 5, 4, 3, 8, and value we require value. We don't require any quantity. Quantity is not given for current year. Okay, because we don't require it. Then P0 Q0 is nothing but weights V. P0 Q0 is equal to weights when V. Okay, P0 3 into 30 is equal to 90. 4 into 50 is equal to 200. 3 into 40 is equal to 120, 2 into 20 is equal to 40, 5 into 10 is equal to 50. Now we need to okay, we got V, and okay, we need to calculate the price relatives. That is, price relatives is nothing but, as we know the formula for price relatives, P1 by P0 into 100, P1 4 by P0, okay, 4 by 3, 4 by 3 is equal to 1.333, that is into 100, 133.33. 5 by 4 is equal to 1.25 into 100 is equal to 125, and 4 by 3 is equal to 1.333 into 100 is equal to 133.33. Then 3 by 2 is equal to 1.5 into 100 is equal to 150. 8 by 5 is equal to 1.6 into 100 is equal to 160. Now we need to find log values for these price relatives. That is 133.33 log value is 2.1249, 125 log value is 2.0969, 1.3333 133.33 log value is 2.1249, 150 log value is 2.1761, 160 log value is 2.2041. okay, now we need to multiply the weights with log p values. That is 90 into 2.1249 is equal to 191.241. 200 into 2.0969 is equal to 419.380. 120 into 2.1249 is equal to 52.988. 40 into 2.1761 is equal to 87.044. 50 into 2.2041 is equal to 110.205. okay, with this we got all the required values, that is sigma v log p by sigma v, okay, weights into log p by sigma okay, sum of the weights. That here sigma v log p is equal to, we got 1062.858, and sigma v we got as 500. Substituting these values, p01 is equal to antilog of 1062.858 by 500, which is equal to antilog of if you multiply 1062.858 by 500, you will get 2.1257. if you antilog 2.1257, you will get 133.6. therefore the price index for 1983 will be 133.6. okay, now we will consider quantity index number. okay, quantity index number. Quantity indices are used to measure average changes in the quantities. Right? These are useful to measure and compare the physical value of goods produced or marketed or distributed in the given year with reference to the base year. With reference to any base year, right? Unlike price indices, quantity indices are not widely used. Among quantity indices, the production indices are highly effective indicators of the level of production in a country. okay, if you want to know the status of country, you must know the production of that country, right? uh, the quantity indices are constructed by using various formulae of price indices by interchanging q to p, p to q, interchanging q to p and p to q, right? As we will see, first is last pair quantity index q01, whereas in p01 we have sigma p1 q0 by sigma p0 q0. Here we replace p with q, q with p, right? q01 is equal to sigma q1 p0 by sigma q0 p0 into 100. okay, whereas Paaschi's quantity index q01 is equal to sigma q1 p1 by sigma q0 p1 into 100. whereas Fisher's quantity index Q01 is equal to, okay, under root sigma Q1 P0 by sigma Q0 P0 into sigma Q1 P1, okay, sigma Q1 P1 by sigma Q0 P1 into 100, okay. These are the formulas. Based on these, we will consider one problem, and for the better understanding of the these quantity index numbers, right? He has given information regarding quantity indices, okay, asked to find quantity indices, and by using Laplace method, Parse's method, Fisher's ideal method, and he has given items A, B, C, D, E. Base year is considered as 1980, and current year is 1983. Base year prices are 4, 3, 5, 8, 10, whereas quantities are 40, 80, 50, 40, 30, and current year prices are 5, 4, 8, 10, 12. Quantities are 50, 100, 50, 50, 40. Right? These are given. Based on this information, we need to compute the quantity indices for 1983. Then we require Q1 P0. Q1 P0 is Q1 is we are having 50, P0 is 4. In the same manner, okay, P0 is nothing but price year base year prices. Q1 is current year quantities. If you multiply base year prices with current year quantities, you will get 4 into 50 200, 3 into 100 300, 5 into 50 for 5 into 80, okay, which was wrongly entered. 5 into 80, that is 400. 8 into 5, sorry, 8 into 50 is equal to 400, and 10 into 40 is equal to 400. 10 into 40 is equal to 400. Then P1, Q1 P1, that means quantities of the current year multiplied with the prices of the current year. That is P1 Q1, 5 into 50 250, 4 into 100 400, 8 into 80 640, 10 into 50 500, 12 into 40 480. Now Q0 means quantity of base year into prices of the current year. Q0 P, okay, if you multiply Q0 P1, you will get Q0 P1, that is quantities of base year multiplied with current year prices, you will get Q0 P1. That is quantities of base year, okay, 40, and prices of current year 5. 40 into 5 200, 80 into 4 320, 50 into 8 400, 40 into 10 400, 12 into 30 360. Now Q0 P0 is equal to, that means base year quantities, base year prices, when we multiply, we will get Q0 P0, that is 4 into 4 40, 163 into 80 240, 5 into 50 250, 8 into 40 320, 10 into 30 300. Okay, if you add all this, that means Q1 P0, if you add, you will get sigma Q1 P0, which is equal to 1700. If you add Q1 P1 values, you will get sigma P1 Q1, that is 2270. If you add Q0 P1, okay, you will get sigma Q1 Q0 P1, that is 1680. If you add sigma Q0 P0, you will get sigma Q0 P0, that is 1270. We got all these required, and we need to substitute the same in the different formulas that are asked to find out, that is Laplace quantity index. If you substitute, which is equal, the formula is given as Q01 is equal to sigma Q1 P0 by sigma Q0 P0 into 100. Okay, that is sigma Q1 P0 we got as 1700, and sigma Q0 P0 is 1270. Therefore 1700 by 1270 into 100 is nothing but 1700 by 1270, you will get 1.338. If you multiply the same with 100, you will get 133.8. Okay, next Parse's quantity index, that is Q01, which is equal to sigma Q1 P1 by sigma Q0 P1, okay, into 100, which is equal to sigma Q1 P1, we know that 2270 by sigma Q0 P1 we got as 1680, which is multiplied by 100. You will get if you divide 2270 by 1680, you will get 1.351. If you multiply the same 1.351 into 100 with 100, you will get 135.5. This is called Parsh's quantity index. Okay, then we see for Fisher's quantity index, that is under root sigma q1 p0 by sigma q0 p0 into sigma q1 p1 by sigma q0 p1 into 100. If you substitute, that is sigma q1 p0 is equal to, okay, we got how much we got, and that means last pairs and Parsh's quantity indexes, and okay, last pairs index multiplied by Parsh's index and square rooted, right? That is, you got last pairs index is 1.338 into 1.351 under root, okay, into 100. If you okay multiply 1.338 into 1.351, you will get 1.807638 under root into 10, sorry, 100. Okay, under root 1.807638 into 100. Then if you under root to find out the under root value, you will get 1.3445 and 200 is equal to 134.45 will be the Fisher's quantity index. Okay, Fisher's quantity index. Now we'll go for value index numbers. Okay, and the value of commodity is the product of its price and quantity. The value index can be obtained by expressing the total value of current year as percentage of the total value in the base year. It measures the changes in the actual value between two periods of comparison, that is current year and base year. Symbolically, V is equal to sigma P1 Q1 by sigma P0 Q0 into 100. Okay, where V is equal to value index, sigma P1 Q1 is equal to total value of all commodities in the current year. Okay, then sigma P0 Q0 is equal to total value of all commodities in the base year. When the value of current year and base year, okay, are given, the value index can be calculated by using the formula, that is V is equal to sigma V1, that means current year value index y, okay, by to, value base year value, okay, the total of values of all commodities in the base year. Sigma P1 Q1 is nothing but V1 will, okay, V1 is equal to total values in the current year, V0 is equal to total values in the base year, right? Yeah. Now we will consider one problem for better understanding. Okay, that is construction of value index. Okay, he has given uh, commodities 1 2 3 4, and he has given 1975 and 83. We consider 1975 as base year and 1983 as current year. The base year prices are indicated with P0 and the quantities are with Q0. Okay, and okay, current year prices are indicated with P1 and quantities are with Q1. Now, as we require value price index, we need to multiply current year quantities with current year prices and base year quantities with base year prices, right? That is sigma P1 Q1 by sigma P0 Q0 is equal to value index into 100. That here we got P1 Q1, okay, current year prices with current year quantities. 6 into 15, that is 90, 8 into 15 120, 6 into 10 60, 8 into 20 160, P0 Q0, okay, 4 into 10 40, 10 into 10 100, 8 into 4 32, 5 into 7 5 into 15 75. Sigma P0 Q0 is equal to 247. If you substitute the same in the V is equal to 430 by 247 into 100, okay, 430 by 247 into 100, which is equal to 174.08. Therefore, value index for 1983 is equal to 174.08. Right. Now, we will consider tests of index numbers. Okay. What are the tests? Okay. We need to consider for the index numbers. We will see. Okay. First, unit test. Before that, I would like to say a few words. There are several formulae to construct index numbers. Generally, it is a problem to select the most appropriate formula among all the given formulas, okay, to measure the price level changes with the perfection. A number of mathematical tests have been designed to overcome this problem. According to these tests, any formula which satisfies them can be considered perfect. Okay, if the formula does not satisfy these tests, it is regarded as imperfect formula to measure the price level changes. These mathematical tests are also known as tests of consistency or adequacy of an index formula or criteria for a good index number. Right. We'll see tests of index numbers now, and first we will have unit test. We have the four tests in this unit test, time reversal test, factor reversal test, and circular test. First we will discuss unit test. Okay, in this test, formula used to compute an index number should be interdependent should be independent of units in which the price and quantities of various commodities are quoted. For instance, the prices are quoted in rupees, whereas quantities are quoted in meters, liters, kilograms, etc. Okay, which are absolute units of measurement. If the index is constructed by using these absolute values, the result must be independent of them. This implies that the value of index number should be in relative terms, that is, percentages rather than in absolute terms, right? Because the absolute values are not useful for comparison and drawing valid inferences unless they are expressed in relative terms. All the formula used for conducting the index numbers for constructing the index numbers except simple aggregative method satisfy this test, right? uh, Next we'll see time reversal test. Time reversal test was propounded by Professor Irving Fisher to test the time consistency of index number formulae. This test enables us to determine whether the formulae can work both ways in time, that is, backward and forward. According to Fisher, the formula for calculating an index number should be such that it gives the same ratio between one point of comparison and the other, no matter which of the two is taken as a base. Or putting it the other way, the index number reckoned forward should be the reciprocal of that reckoned backward. Okay, as per this test, the product of two indices computed by interchanging current year as a base year and base year as a current year should be unity. Okay, for example, For example, the index for 1983 with 1980 as base year and index for 1980 with 1983 as base, and their product should be unity. If the product is not unity, it indicates that the formula used for the construction of index number does not satisfy the real the time reversal test. It implies that there is an inherent bias in the formula. Okay, inherent bias in the formula. The time reversal test is symbolically expressed P01 into P10 is equal to 1, where P01 is equal to index without factor 100 for year 1 on year 0 as base. Okay, 1 on current year and 0 is base year, right? And P10 is equal to index without factor for year 0 on year 1 as base. Okay. For instance, if the price of a commodity has increased to rupees 4, okay, in 1983 as compared to rupees 2 in 1980, it means that the prices of 1983 is 200% of 1980 prices, and the prices of 1980 is 50% of 1983 prices. These two figures are reciprocal of one another and their product is equal to 1, that is 200 by 100 into 50 by 100 is equal to 1. Okay. Okay, the following formulas given in the PPT. Okay, the formulas which are given in the PPT satisfy the time reversal test. Fisher ideal formula is there, Marshall Edgeworth formula is there, Kelly's formula is there, simple geometric mean of price relative formula is there, simple aggregative index with fixed weights is there, the weighted geometric mean of price relative is there, and Walsh price index. Okay, all these will satisfy the time reversal test. We'll consider one problem. Okay, that is ideal, and that is Fisher's ideal index satisfied ideal index text. Okay, we'll see whether the given data will problem will satisfy the whether satisfy or not. We'll look at the PPT. It is given that commodities are given A, B, C, D. Base year is 1980. That is, base year prices are indicated with P0, Q0, and current year prices are current year prices, that is 1983 prices are P1, and quantities are Q1. Right. Base year prices are 8, 4, 6, 10, 12, and base year quantities are 50, 100, 120, 80, 50. Current year prices are 10, 6, 8, 12, 14. Current year quantities are 60, 120, 140, 100, 80. These are given. Based on these, we need to find out P0, Q0. That means current year, base year prices multiplied with base year quantities. That is base year prices, base year quantities. 80 into 50, 400. 4 into 100, 400. 6 into 120, 720. 10 into 80, 800. 12 into 50, you will get 600. Okay, now we need P0, Q1. P0 current year prices, base year prices with current year quantities. Base year prices 8 into current year quantity 60. Okay, that is 480. 4 into 120, 480. 6 into 140, 840. 10 into 100, 1000. And 12 into 80, that is 960. Now we need a P1, Q0. P1 means current year prices into base year quantities. That is 50 into 10, 500. 100 into 6, 600. 120 into 8, 960. And 80 into 12, 960. 50 into 14, 700. Then P1, Q1, that is current year prices with current year quantities. 10 into 60, 600. 6 into 120, 720. 8 into 140, okay, 1120. 12 into 100, 1200. 14 into 80, 1120. Now we need to add all these. That is P1, P0, Q0. If you add, you will get sigma P0, Q0. That is 2920. Okay. If you add sigma P0, Q1, you will get 3760. If you add P1, Q0, you will get sigma P1, Q0. That is 3720. And if you add P1, Q1, you will get sigma P1, Q1, which is equal to 4760. Okay, as we know the formula for the Fisher's ideal index, that is we need to first find out the Fisher ideal index, and we need to test the same for whether it satisfies the time reversal test. First we will look at this problem, and if you substitute the same, and that is P01 is equal to sigma under root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into 100. Okay, if you substitute the values, P01 is equal to under root 3720 by 2920 into 4760 by 3760 into 100. If you under root 1.27, that is 3720 by 2920, you will get 1.27, and 4760 by 3760 is also, you will get same 1.27. Under root 1.27 into 1.27, you will get that is 1.27 square under root 1.27 square. Root and the square gets cancelled. You will get 1.27 into 100, which is equal to 127. Therefore, price index for 1983 is equal to 127. Fisher's ideal index, whether satisfies the time reversal test or not, we will see now. P01 into P10 is equal to 1. Okay, and that should be satisfied. P01 That means sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1, whereas P10 is equal to sigma P0 Q0 by sigma P1 Q1 into sigma P0 Q0 by sigma P1 Q0. That is nothing but P0 1 places are taken by the 0 places are taken by the 1. P01 in P01 sigma P1 Q0 in P10 sigma, okay, P0 Q1 P0 Q1, right. These are the changes. Now we need to multiply P01 into P10. You will get sigma P1 Q0, okay, by sigma P0 Q0 into sigma uh, P1 Q1 by sigma P0 Q1. Now sigma P0 Q1 by sigma P1 Q1, sigma P0 Q0 by sigma P1 Q0. Okay, sigma P1 Q0 Q0 gets cancelled. All are gets cancelled, only 1 is left. Okay, under root 1 is equal to 1. Hence the Fisher ideal index satisfies the time reversal test. We can prove that. Third is factor reversal test. Okay, another test suggested by Professor Irving Fisher to examine the consistency of index number formula is factor reversal test. According to this test, the product of price and quantity indices without factor 100 should give true value ratio. Okay, when these two indices were computed for the same data and for the same current and base periods, right? According to Professor Fisher, just as our formula should permit the interchange of the two times without giving inconsistent result, okay, so it ought to permit interchanging the prices and quantities without giving inconsistent results. That is, the two results multiplied together should give the true value ratio. In other words, the change in the prices, okay, multiplied by the change in the quantity should give us total change in the value, that is true value. Okay, factor reversal test can be symbolically stated as P0 into Q1, okay, Q01, which is equal to sigma P1 by Q1 by sigma P0 by Q. That means current year prices and current year quantities, sum of the current year prices, product of sum of the product of current year prices into current year quantities by sum of the product of base year prices with base year quantities, right? Where P01 is equal to index for the okay, price index for the year 1 and the year 0 as base. Q01 is equal to quantity index for the year 1 and the year 0 as base, right. Sigma P1 total value in the current year, sigma P0 Q0 is total value in the base year, right. Now if the product of the price and the quantity indices is not equal to the true value ratio, it is assumed that there is an error in the formula. Okay, except Fisher's ideal index, none of formula satisfy the time reversal test. Okay, none of the formula right factor reversal test. That is, we'll see. Let us see how Fisher ideal index satisfy. We'll see. P01 we have given that is sigma P1 under root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 without factor 100, right. Changing P1 P to Q and Q to P, we will get Q01, that is sigma Q1 P0 by under root sigma Q1 P0 by sigma Q0 P0 into sigma Q1 P1 by sigma Q0 P1. Okay, now P0 in 1 into Q01 under root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into sigma Q1 P0 by sigma P0 Q0 into sigma Q1 P1 by sigma Q0 P1. If you cancel, which will go first? Sigma P1 Q0 by sigma P0 Q0 won't go. Sigma P1 Q1 by sigma P0 Q0 won't go. Okay, sigma P0 Q1 P0 will get cancelled. Okay, and sigma okay, the remaining will be under root sigma p1 q1 by sigma p0 q0 into sigma p1 q1 q1 p1 is nothing but the order, it won't make any difference. Sigma q1 p1 is equal to sigma p1 q1 by sigma p0 q0, right, which gives us under root sigma p1 q1 by sigma p0 q0 whole square. P01 into q01 is equal to under root sigma p1 q1 gets square and root gets cancelled. We will have, okay, p01 into q01 is equal to sigma p1 q1 by sigma p0 q0. Okay, sigma p0 q0. Okay, we will consider one problem for this. Okay, compute Fisher's ideal index and test whether it satisfies factor reversal test or not. Okay, items are given, base period and current period are given. Items are A, B, C, D, E. Base period, okay, prices are taken as P0 and quantities are Q0. Prices are 6, 2, 4, 10, 8. Quantities are 50, 100, 60, 30, 60. Current period prices are taken as P1 and quantities are Q1. Prices 10, 2, 6, 12, 10. Quantities are 60, 120, 80, 20, 50. P0, Q0. Okay, 6 into 50, 300. 2 into 100, 200. 4 into 60, 240. 10 into 30, 300. 8 into 60, 480. P0, Q1 is equal to, that is 6 into 60, 360. 2 into 120, 240. 4 into 80, 4. P0 Q0, first we need to calculate P0 Q0, that's 6 into 50, 300. 2 into 100, 200. 4 into 60, 240. 10 into 30, 300. 8 into 60, 480. P0 Q1 is equal to P0 prices of the base year and quantities of the current year. 50 into 60, okay, P0 Q1, that is P0 is 6, base year prices with current year quantity 60. Okay, 6 into 60, that is 360. 2 into 120, 240. 4 into 80, 320. 10 into 20, 200. 8 into 50, 400. Then P1 Q0 is equal to, that means prices of the current year with the quantities of the base year. 50 into 10, 500. 100 into 2, 200. 6 into 60 into 6, that is 360. 30 into 12, 360. 10 into 60 into 10, 600. Okay, in the same manner, P1 Q1, that means current year prices multiplied by current year quantity. 10 into 60, 600. 2 into 122, 46 into 80, 480. 12 into 22, 40. 10 into 50, 500. If you add all these, that is P0 Q0, if you add, you will get sigma P0 Q0, that is 1520. If you add sigma P0 Q1, you will get sigma P0 Q1, that is 1520. P1 Q1, if you add P1 Q1 values, you will get sigma P1 Q0. P1 Q0 values, you will get sigma P1 Q0, that is 2020. If you add P1 Q1 values, you will get sigma P1 Q1, that is 2060. Okay, here we have all the required terms and we need to substitute the same in the formula. That is Fisher's, okay, ideal index is equal to P01 is equal under root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into 100 factor. If you substitute the same, P01 is equal to under root 2020 by 1520 into 2060 by 1520 into 100. 2020 by 1520, 2060 by 1520, which you will get 2020 by 1520 is nothing but 1.328. 2060 by 1520 is equal to 1.355, which is into 100. If you multiply 1.328 into 1.355, you will get 1.79944 under root into 100, which is equal to 134.41. Price index for current period is equal to 134.1. Factor reversal test is satisfied if P01 into Q01 is equal to sigma P1 Q1 by sigma P0 Q0. Okay, P01 is equal to, we know that sigma P1 Q1 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 without factor. That is Q01 is equal to, we need to interchange the P values with Q, right? That is sigma Q under root sigma Q1 P0 by sigma Q0 P0 and into sigma Q1 P1 by sigma Q0 P1. If you multiply P01 into Q01, you will get under root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into sigma Q1 P0 by sigma Q0 P0 into sigma Q1 P1 by sigma Q0 P1. Okay, which gives rise. If you substitute the same in the formula, that is P01 into Q01, under root you will get under root 2020 by 1520 into 2060 by 1520 into 1520 by 1520 into 2060 by 20 2020 20 to 20, that means 2020 gets cancelled, 1520 gets cancelled. You will have 2060 by 1520 and 2060 by 1520, right? Now under root 2060 by 1520 into 2060 by 1520, you will have 2060 by 1520 that is whole square under root whole square 2060 by 1520 whole square, which is equal to under root and square gets cancelled. You will have 2060 by 1520, which is equal to sigma P1 Q1 by sigma P0 Q0. Hence Fisher ideal index satisfies the factor reversal test. While computing various kinds of indices, okay, the factor reversal test is completely ignored on account of its strong restrictions involved to prove this test. Okay, next we'll have circular test. Circular test first proposed by Westergaard and was highly favored by C.M. Walsh, who has named it circular test. This is an extension of time reversal test. According to this test, the formula used to compute the index, okay, should work in circular manner. In order to satisfy this test, the product of price indices over a period of year should be unity. The indices for the different years are computed without referring back to, okay, original base in each time. The circular test suggests that if an index is computed for a year A on the basis of year B, and for the year B on the base year C, and for the year C on the base year A, and the product of all these indices should be unity. For example, there are three indices such as 0, okay, P01, P12, P20. The circular test is said to be satisfied if P01 into P12 into P20, which is equal to 1. This test is satisfied only by simple geometric mean of price relative, simple aggregative, okay, method and fixed weights aggregative method. Okay, this test is not satisfied by other formulae used to compute indices such as Laplace, Pacis, Dorbish and Bowley and Fisher's ideal index. This simple aggregative price index satisfies the circular test. We will see here. One example we'll consider for the same. That is, there are three indices such as P01, P12, okay, P12, P20. The circular test is said to be satisfied if P01 into P12 into P20 is equal to 1. Commodities are given A, B, C, D, E, and prices of 1980 and prices of 1983 are also given. 1980 prices are okay, and that is 1980, 83 and 78 prices were given, right? 78%, this is wrongly entered. First we need to enter 78 and middle say 80 and lastly 83. Okay, there is a small correction we need to make. That is 1978 we got 4, 3, 5, 8, 10, and prices in the 1980 you will get 6, 4, 8, 10, 12, and in the year 1983 8, 6, 10, 12, 15. If you sum up prices of the 1978, these are nothing but sigma P0 is equal to 30, whereas 1980 prices are sigma P1 is equal to 40, and 1983 prices are sigma P2 is equal to 51. In order to prove that simple aggregative index satisfies the circular test, we should get P01 into P12 into P20 is equal to 1. P01 is equal to sigma P1 by P0, sigma P0, sigma P12 is equal to sigma P2 by sigma P1, P20 is equal to sigma P0 by sigma P2. Here we know the values sigma P0 is 30, sigma P1 is equal to 40, sigma P2 is equal to 51. Substituting the same in the 40 by 30 into 51 by 40 into 30 by 51, which is equal to 1. Okay, hence the simple aggregative method of index satisfies the circular test. Okay, with this we have completed the tests of indices, and thank you.